Welcome back to The Explainer. So today, we're diving into a genuinely thrilling shift in how we build software. Honestly, we're moving way past the days of just hacking together isolated standalone AI bots. Instead, we're talking about how to orchestrate a massive, interoperable digital factory. If you've ever felt the absolute agony of wiring together, a dozen fragile API connections just to get your AI to do one tiny thing, well, you're in exactly the right place. Grab your focus because we are going to unpack the protocols that make this entire virtual workforce a reality.
Okay, let's look at this bold manifesto straight from our source paper today. It says, software's next evolution isn't written, it's orchestrated by interoperable agents. That is a massive hook for all you vibe coders out there, right? Our primary job, it's no longer just writing raw syntax or endlessly debugging custom REST wrappers. No, our job now is building and managing the actual systems that produce the code. You're not just a builder anymore, you're an orchestrator. But for that to work, your machines actually have to know how to talk to each other.
So the absolutely crucial thing to understand here is the core equation of this new era. An agent equals a model plus a harness. Now, we all know the model part, right? That's the brain, the LLM. But the harness, that's where the real magic happens. The thing is, your harness requires standardized, open protocols. Without them, every agent you build is just this fragile, custom-built machine trapped in the garage. It can't scale, it can't share tools, and it's going to break the literal second in API updates. We absolutely need industry standards to let your machinery safely interact with the rest of the world.
So, to help you build out that digital factory, here's our roadmap. We've got an alphabet soup of protocols to decode today. We'll start with the era of interoperability, move into MCP for tool connections, A2A for agent collaboration, A2UI for user interfaces, and finally, UCP and AP2 for autonomous commerce. Let's get right into it.
Section 1. The Agent Interoperability Era, or moving beyond the monolith. Think back to early web apps for a second. They're these massive, monolithic code bases, right? Well, AI has kind of been doing the exact same thing. We've been building these giant Swiss Army knife agents, and eventually, they just hit a massive ceiling of scaling friction and contextual overload. The solution here? Specialization and interoperability.
Section 2. MCP, the Universal Socket, connecting models to tools. Let's look at our first major protocol. You can really just think of MCP as the USB-C cable for your agent's harness. Back in the old days, which, let's be real, was like a few months ago, every single new connection required a bespoke REST wrapper, custom JSON parsers, manual token refresh policies, just a massive headache. MCP completely replaces all of that friction. It instantly connects your models to databases, file systems, and web APIs using one standard socket. Take a look at the math here, because this perfectly explains why MCP is such a total game changer. It solves the M/M prototyping problem. Say you have 5 different LLMs and 10 different tools. Traditional integration means you have to write and maintain 50 bespoke integrations. It's an absolute nightmare. MCP beautifully reduces this to a linear scale, O of n plus m. You just connect the model to the protocol and the protocol to the tools. If the tool API changes, your whole system doesn't just spontaneously collapse. It's so elegant. Now, if you're ready to start consuming MCP servers, here's a rapid-fire toolkit for you. First up, the do's. Do use RAG to dynamically load tools only when you actually need them, so you don't dilute the model's attention. Do use internal gateways for governed data. And crucially, when things break, and they will, do use the MCP inspector or Chrome DevTools to debug the transport pipes directly, rather than just blindly tweaking your prompts. Okay, now the don'ts. Don't build a custom wrapper if you can just consume an existing MCP server. Don't ever hard-code credentials into your prompts. And please, for sure, don't tie your core business logic to unverified public MCP servers in production.
Section 3. A2A, building virtual workforces, the factory radio. Now that our tools are plugged in, we need our agents to communicate. If MCP is our USB-C cable, A2A is the factory radio. When you break your giant monolith down into specialized sub-agents, they have to talk. A2A abstracts away all those messy underlying networking frameworks, the different programming languages, the payload disparities. It basically lets your central orchestrator easily hire remote specialists, regardless of how they were actually built under the hood.
Which naturally brings up a really critical architectural question. If we're just delegating tasks to external specialists, why can't we just treat them like standard tools? Well, think about a kitchen renovation. You can buy a hammer and do it yourself, or you can hire a specialist. A hammer is a passive instrument, right? You fire off a command and just hope for the best. But a hired specialist? They're a collaborative partner. They're going to hit edge cases, they might pause to ask questions, and they'll negotiate trade-offs with you.
And that brilliantly highlights the fundamental difference between bounded and unbounded domains. Tools live in bounded domains. They're fire and forget, single-formatted requests. Agents, on the other hand, live in unbounded domains. They're dealing with messy, real-world ambiguity and multi-turn conversational states. Trying to force an agent into a standard tool wrapper creates what we call the go-to problem. Your control flow leaves your nice, structured context and honestly might never return. The A-to-A protocol isolates all that messy, interrupted state negotiation, which keeps your actual tool layer clean and perfectly predictable.
So, how do we make these agents discoverable? Enter the agent card. This is literally the standardized machine-readable CV of the AI world. It clearly details what tasks an agent can perform, its security policies, and its interaction schemas. With this card, developers can list their specialized agents on public registries like the Google Cloud Marketplace and actually monetize them using an agent as a service model. You could literally build an expert compliance agent in your bedroom, publish its agent card, and license its expertise to orchestrators all over the globe. Section 4. A2UI Safe Generative Interfaces. Going from raw JSON to interactive displays. You know, when humans share insights, we draw charts. We don't just hand each other raw JSON blobs. But that is exactly what our agents usually do, forcing us to totally break our vibe coding flow just to build a front end. A2UI completely fixes this. It acts as a generative display window, dynamically whipping up safe, interactive visual components for human operators right on the fly.
But wait, how do we actually do this safely? Because you absolutely cannot just let an LLM generate arbitrary executable code. That is a massive security nightmare. It's like the difference between shipping raw audio and shipping sheet music. A composer doesn't hand an orchestra a raw audio recording, they hand them sheet music, which the musicians then safely interpret on their own instruments. A2UI is basically sheet music for user interfaces. The agent just declares its intent. It requests trusted UI Lego blocks from a catalog, and then your client renders it securely. The agent never actually writes executable code itself.
There are two main patterns to actually implement this. First is the intent-driven pattern. This is where you let the LLM dynamically generate the layout using the SDK. This is super helpful for open-ended stuff, like asking an agent to compare these two regions. The second pattern is input-driven. Here, a tool returns a fixed, deterministic A2UI structure. This saves a ton of LLM tokens and is perfect for things you know won't change much, like a standard sales dashboard. Combine either of these patterns with a persistent Canvas workspace, and suddenly you have this amazing living document where you and your agent can collaborate in real time. Okay, moving right along to Section 5, UCP and AP2. Agentic commerce, or the global supply chain. Reading data and generating neat UI is great, but eventually we want our agents to take actions that carry actual, real-world financial weight. So let's look at the highly anticipated protocols that allow agents to transition from simple read-only tasks to safely executing autonomous financial transactions. First up is UCP, the Universal Commerce Protocol. Think of this as the ultimate universal food delivery translator. Imagine it's 2 a.m., you're starving, and you want a burrito. Without UCP, your poor AI has to scrape some poorly designed restaurant website, try to somehow click a tiny checkbox for extra guacamole, and just pray the whole thing doesn't crash. But with UCP, the restaurant publishes its menu in a standard machine language. This lets your agent negotiate directly with the restaurant's system to build your absolute perfect order entirely friction-free.
All right, so the burrito's in the cart, but how does the AI actually pay for it? You are definitely not just going to hand your AI your debit card, right? That is where AP2 comes in, the Agent Payments Protocol. Think of AP2 as a highly secure digital lockbox, or maybe a parent's credit card with incredibly strict spending rules. It provides a cryptographic promissory note. You pre-authorize a specific mandate, let's say a maximum spend of exactly $25. AP2 ensures the AI only pays that exact authorized amount, completely stopping it from accidentally or maliciously going off and buying a $1,000 TV.
Notice the totally beautiful tag team dynamic between these two layers here. UCP is the brain and the cart. It discovers the catalog, decides what to actually buy, and builds the order. AP2, on the other hand, is the wallet and the guardrails. It manages the authorization, ensures strict accountability, and stops agent hallucinations from accidentally draining your entire bank account. Combining these two specific layers is what makes machine-to-machine microtransactions both incredibly frictionless and fully verifiable.
Which brings us to our final stop, Section 6, Orchestrating the Future. Going from builder to orchestrator. By adopting these standardized protocols, MCP for your tools,
A to A for collaboration, A to UI for interfaces, and UCP and AP2 for commerce, you are permanently eliminating the crushing technical debt of bespoke integrations. You get to stop being a mechanic, constantly wiring up fragile APIs, and you finally become a true architect.
So I want to leave you with this final, somewhat provocative thought. Take a hard look at your current AI projects. Ask yourself, are you spending your days building fragile, custom wrappers that are just going to break next week? Or are you adopting the protocols that will let you orchestrate a truly interoperable global virtual workforce? The tools are literally right here. It's time to stop hard-coding connections and start engineering the future. Thanks so much for hanging out with me on this explainer. Now get out there and orchestrate something amazing.